Timing car is a fascinating car that is an all-in-one device having electronic circuit to sense and record its motion. There is no need of any external photo gates or motion sensors to be mounted with the track. It does not require any external digital timer or data logging interfaces to record motion. It has advanced electronics built in with microsecond resolution timer to record up to 9,999 time distance points at every 2 mm of its motion. The amazing part of this product is that it can sense and record motion in fine details even on a curved track, which is not possible with other products. Let me show you the analysis of a motion on a potential well track, where conversion of energy can be studied between kinetic and potential energy. The recorded data in the car can be transferred to a computer, and we can plot the results. Here we analyze the time distance and time velocity graphs, and we can see that the velocity is the maximum at the bottom of the track and zero towards the end, where car reverses its direction. Now the best part is that this curved track can take any shape, sloping, up, down, roller coaster, even a track having bumps or potholes. Tracks can also have friction overlays. Any kind of track that a student can think of is possible. Anyone familiar with linear air track to conduct the conservation of momentum experiments using digital timer and photo gates can well appreciate how difficult it is to set up the experiment so that it gives convincing and repeatable results, let alone the noise of the blower, which makes it impossible to discuss anything during the experiment. Timing car setup is a replacement for linear air track-based experiments, by which we can conduct not only experiments performed by linear air track and other dynamic systems available in the market, but many more, for example analyzing motion on curved track in fine details with large amount of data. Timing car is a little bit more expensive than linear air track, but it is worthwhile to pay a little more, in the short, for that little price. It performs many more experiments which air track can't, and the best part is that it is easy to work with and students and teachers don't have to go through that messy and infuriating noise of a blower which they experience while working with air track. Timing car indeed is a superb replacement of air track-based experiments. Now let me show you how this novel product can be used to conduct this experiment in an extremely easy setup. We have two cars with elastic bumpers. We can synchronize the time of both cars by starting their timers using a remote. Then we give an instantaneous motion to one of the cars by pressing striker bumper, and can see the effects of collision and rebounds. Now both cars have recorded data independently of their motion. The time distance graph shows the motion of two cars while they interchange their velocity at the point of collision. Let us superimpose the time velocity data and see it. At the point of collision, both objects of the same weight exchange their velocity and momentum. The slight slope in the velocity here shows the effects of friction, but the important point is that the conservation of the momentum is always valid at the points of collision and rebounds. The slight friction between track and car wheels does not affect the results. There are several bumper and weight accessories that can be fitted to the car and track. Bumpers are used in mostly all linear motion experiments. Elastic bumper, Velcro bumper, crash test bumper are usually fitted on timing car. Striker bumper accessory is fitted with the track for initial momentum to car. Weights can also be mounted on the car. A special accessory that can be attached to the car is a crash test accessory, which is unique and comprises of the elastic bumper, release bumper, with a crumple zone and a magnet-loaded steel ball. This can be used to analyze the effectiveness of the bumper during crash test. So go ahead and explore laws of motions with a whole new perspective with Intasaw's timing car and accessories.